This video is on comparing quadratic functions. We will be using Desmos to help compare quadratic functions. The baseball team has decided to have a throwing contest. Below is the data for 3 different players. In order for us to compare these quadratic functions, we need to be able to have the information from each person. So we need to know the x-intercepts, the y-intercepts, and the vertex for each of the people. So for Joe, we already have a graph, which is in time and height. So if we were to look at this, we're going to estimate for Joe. Joe's y-intercept looks to be at about 0 and roughly underneath half, so I'd say roughly 3 feet. So I'm going to put approximately 3. Joe's x-intercept, since it only crosses or touches the x-axis once, would be at about, let's say about 2.5, 0. And then we also need to find, so this would be his x-intercept. This would be his y-intercept because it's hitting the y-axis. And we also need to find Joe's vertex, would be about here. So Joe's vertex would be at about, so if we found the time, maybe at about 1 1/4, maybe a little less. I'm just estimating here, about 1 1/4, comma, maybe about 78. So this is Joe's information, and this is just off of the graph that we can see because we don't have an equation for it, so we have to estimate to see what values are where. For Henry, we have a table here. So what we can do is we can actually find the regression equation for Henry to find his actual information. So let's go in and find the regression for Henry. So if I go into Desmos, I want to put in Henry's table, which his time was x, so that was at 0.5, 1, 2, 3. And then I had his height for the x value of 0.5 was at 37.5 feet. Then at 1 second it was 63. Then it was at 90, and then it came back down to 85. I'm going to delete these. I'm going to do regression. So that is y sub 1 tilde. Since this is quadratic, this is going to be a x sub 1 squared plus b x sub 1 plus c. So we have an a value of -16, a b value of 75, and a c value of 4. That means that we can actually write his equation out. So I'm going to write his equation as Henry's is y equals -16 x squared. And then we had a 75 for our b and 4 for our c. So plus 75x plus 4. With this, we can find his y-intercept, his vertex, and his x-intercept. So y-intercept will actually be at 0.4 because that's the constant. His x-intercept, so let's go and find that on Desmos. X-intercept is where it hits the x-axis. So it's going to be 4 and 74/100, comma 0. And we need to find his vertex. So let's go back to our Desmos screen for that. I'm going to zoom out, and I'm going to zoom in at his vertex up here, which is roughly 2 and 34/100 and 91 and 89/100. So his vertex is at 2 and 34/100, comma 91 and 89/100. So that tells us his information. So on Michael's, we can actually do the same thing. Since we already have the equation, we can just plug that into Desmos and find the information. So for Michael's, his y-intercept will be at 0.5 since that is the constant. We need to find the x-intercept and the vertex. And we can find that from Desmos. So we're going to go into Desmos. We're going to type in Michael's equation, which was y equals negative 16x squared plus 50x plus 5. And I'm going to hit my home button so then I can find his information. We know his y-intercept was at 0, 5. His x-intercept is at 3 and 22 hundredths, comma 0. And his vertex is at 1 and 56 hundredths, comma 44 and 6 hundredths. So I'm going to write that information down. His x-intercept was at roughly 3 and 22 hundredths, comma 0. And its vertex was at 1 and 56 hundredths, comma 44 and 6 hundredths. Now that we have all of the information for them, we can actually compare because we've seen it in a graph, in a table, and an equation. We want to be able to find all the pieces of information, which we could have algebraically as well. So the first question says, whose ball was in the air the longest? So to be in the air the longest, it's from the starting point until it hits the ground. So how long, if we look at the x-intercepts, we're going to look at the x-intercepts for that. So Joe's x-intercept his was at 2.5, so roughly 2.5 seconds. Then we have Henry, which was roughly 4 and 74 hundredths seconds. And then we have Michael, which was approximately 3 and 22 hundredths seconds. So who was in the air the longest was Henry, because Henry's ball was in the air for 4 and 74 hundredths seconds. So Henry's baseball for 4 and 74 hundredths seconds. Henry's baseball was in the air the longest for 4 and 74 hundredths seconds. We found that because we had all of their x-intercepts. Question 2 says, who threw their ball the highest? The highest would be looking at the y, or the vertex. So we're going to look at the vertex, which for Joe, his vertex was at 1 and 25 hundredths, comma 78. But since we're looking for who threw the ball the highest, we only want to look at the y value. So for Joe, his y value was at 78. So we're going to be looking for the vertex, but it's the y value of the vertex. Joe was at 78 feet. For Henry, his vertex was at 91 and 89 hundredths feet. And for Michael, his vertex, or his highest, was at 44 and 6 hundredths feet. So who threw their baseball the highest? Henry did at 91 hundredths, or 91 and 89 hundredths feet. So Henry did 91 and 89 hundredths feet is Henry's maximum height. So if you were to determine the winner of the contest, who would you choose and why? Well, Henry had both the ball in the air the longest, so he threw it the furthest, and he also threw it the highest. So I would say that Henry is the clear winner. So I would put Henry because he threw the ball the highest and it stayed in the air the longest. So he is clearly the winner. We can use from a graph a table, or an equation. As long as we can find the important information, we can compare any type of graph, table, or equation, because all of the information comes out from the same thing.